This is a quick review of partial fractions for differential equations. So just remember, if you have any function, let's just call it f of x, and you've got another function p of x over q of x. You're trying to split up q of x and have just constants on top or just simple polynomials. Usually this is so you can integrate the factors much easier than just looking at it and trying to solve it without splitting it up. So we have four main cases. There's a couple other, but you really don't run into them, and you can solve them in very similar ways than this. So case one, we'll have a linear factor. So we'll just have we can have some constant or some function p of x on the top, and it's over x minus r, which is going to be like some constant. So we'll just put the constant a over this, and we'll set it equal to p of p of x. The second case, we have repeated linear factor. So it's going to be the same thing, except this is going to be to some m value. So we could have like x minus 2 squared or x minus 5 to the third or something like that. And this m value depends, or is how many partial fractions you will have. So you'll have the first one for the first order, the second one for the second order, so on and so forth until you hit the last one. The third case is irreducible quadratic. So this is going to be some quadratic that we cannot simplify into two different functions, or not functions, factors. So we could have like something like x minus 2 or 1. So we can't factor it out like that. So we have to put ax plus b. I think of this very similarly to a derivative, because the derivative of this would just be some constant, so we put a. The derivative of this would be some linear function ax plus b, and we're going to just set that equal to p of x, actually p of x over q of x, and we'll show you how to do that later on. The last major case that we'll go with today is the repeated irreducible quadratic, and that means that this quadratic is repeated, and it's the same thing as the linear. It's just a different case, and we just have different coefficients for each time. So anyways, we'll get started with this first problem. So we're told to simplify this function 2 over x squared minus 2x minus 8. So we should start off by actually factoring this out. So we know this will go to 2, and then that's going to be x minus 4 and x minus 4 and x plus 2. Double check that. X squared minus 4x plus 2x minus 8. Yep, we're good. So we're going to actually use the linear factors here because we've got two of them. So what I like to do, instead of having a1 and a2, I usually put a and b. So we will have a over x minus 4 plus b over x plus 2, and that is going to be equal to 2 over x minus 4 times x plus 2. So now we're going to multiply the denominator, so we're going to multiply all of this by x minus 4 and x plus 2, and so that will actually cancel, and we'll just have, so x minus 4, these two will cancel, so we'll just have a times x plus 2 plus b x minus 4, and because we're multiplying both sides, we're going to have that equal to 2. So we'll actually split this out just a bit. So we'll have ax plus 2a plus bx minus 4b is equal to 2. So we'll get the x's together. So we'll have a plus b quantity of x plus 2a minus 4b. Don't know why I put the parentheses there. And we'll have that equal to 2. So what we can do is we know that a plus bx, and there's no x on this side, So we can set a plus b equal to 0. And then we have 2a minus 4b. These have no x in it, and the 2 it has no x in it, so we can say 2a minus 4b is equal to 2. Now we have this system of equations, so we can actually solve this. We're going to multiply this by 2, so 0 times 2 is 0 once again, and we're going to subtract the 2. So 2a minus 2a is 0, 2b minus a negative 4b is 6b is equal to negative 2, which means b is going to be equal to negative 1/3. Now we can substitute back in, so we'll have the original a plus b is equal to 0. We know b is negative 1/3, so a minus 1/3 is 0. We know a is equal to 1/3. We'll actually just go up top here and we'll rewrite it just to get the answer done with. So we'll go back to this step where we actually wrote it out. So we're going to have 1/3 times x minus 4. We can just actually move the entire line over, and then we're going to have minus 1/3 x plus 2. We'll continue on with this problem where we have x squared over x cubed minus 16x. We'll start off by factoring out an x on the bottom, so we'll have x squared minus 16, x squared, x. They cancel, so we're just going to have x over x squared minus 16. We're going to use case 1 again, where we can factor this up into linear components, so x minus 4 and x plus 4. So we're going to have a over x plus 4 plus b over x minus 4 is going to be equal to x over x plus 4 times x minus 4. Once again, we're going to multiply both of these denominators on both sides, so we're just going to have a times x minus 4 plus b times x plus 4. And then this is going to actually just equal x. We're going to multiply this through, so we have ax minus 4a plus bx plus 4b is equal to x. We've got ax and we've got bx, so we're going to just combine them. We're going to have a plus b times the quantity x minus, we'll put these in parentheses, well, plus a negative 4a plus 4b, and that is still equal to x. So we have the x, and this has coefficient of 1. Same thing as last time, so we'll have a plus b is equal to 1. And then we have negative 4a plus 4b is equal to 0. So we can multiply all of this top line by 4 to get rid of this. So we'll have 4a plus 4b is equal to 4. We'll add these two together. The a's cancel, and we'll get 8b is equal to 4, which means b is actually equal to 1/2. Then we can go back to this one. We originally had a plus b is equal to 1, so that means a must equal negative 1/2. So we'll just rewrite this quick. So we know, we'll actually start off with b, so we have this one, so we have 1 over 2 times x minus 4 minus 1 over 2x plus 4.